everyone. Today, a lot of interesting stuff in this algebra is packed. So don't miss it, don't miss it out. So what we see today? Today we see a linear equation of two variables. What's a variable? What's a constant? We are going to see this. Another one, the general term of writing a linear equation expression. We will see that. Uh, Given a linear equation with two variables, we try to see how we represent it in geometry. So we try to draw a graph, and then we find out what are the true sets of this graph or this equation. What pair of numbers make this true? So we will see how we define it geometrically. Another one, we will try to define slope of an equation, a linear equation. So different types of slopes are there: a positive slope, a negative slope, a zero slope, and there are also linear equations with undefined slope. There is no slope on it. So we'll see which one is having what slope. Uh, Another one, what we see is uh, we try to see uh, a linear equation, which means, of course, of same meaning, that represents the same graph. So we will see that. We calculate a slope from given 2 points. When we know 2 points on a given graph, how do we calculate the slope of the graph? That we will see. Another one we cover today is given a slope and 1 point on a given graph. Can we find the equation of the graph? That we will do. And at last, the final portion of today's lesson is going to be uh, given two linear equations of two variables. Can we find a true set that makes both graphs true? That's called simultaneous equation. The set of uh, elements or numbers that make true both. So we'll find out how do we say, and we will also define geometrically what does it mean. How about parallel graphs, which are not the same? How do we find any point that makes true on both, or any point that exists on both graphs? We will have to see that one with lots of examples. Let's go back to page number 1 and do the start of today's lesson. A linear equation and its expressions. Linear equations of two variables. What's a variable? A variable is just a letter in mathematics or mathematical expression. We usually use x, y, and z as variables. In the other way around, we have also letters such as a, b, and c. These are usually called constants, not variables. Here we have an equation, for instance. I put it here in a box. This equation is ax plus by plus c is equal to 0. A, b, and c are considered to be constants. They are a constant number. Later on, when we write the equation, uh, this a, b, and c just are a constant number. What keeps to be a variable is x and y. In some cases of three variables, we can use uh, z, letter w, other letters we can use. X and y are variables, a, b, and c are constants. Let's see how this is represented in actual mathematical expression up here. Ax plus by plus c is equal to 0. This is a general term, when it comes to an actual equation, it looks like 2x plus 3y minus 5 is equal to 0. In here, we have a number just in front of x, another number in front of y. These numbers, which are just comes with a variable r, the coefficients of the variable. The coefficient of x is 2, and the coefficient of y is 3. So 2x plus 3y minus 5 is an expression of two variables. These variables are x and y that represent different numbers. That's why we call it a variable. Okay, next. The statement here, 2x plus 3y minus 5 is equal to 0. We have two things. One is on the left side of 0, which is 2x plus 3y minus 5. And we have 0 on the right hand side of the equality sign. So 2x plus 3y minus 5 is 0 for a certain set of numbers that are to be placed in place of x and y. Here, given one example, if x is equal to 1 and y is equal to 1, is the statement going to be true? Let's see that. 2 times 1 plus 3 times 1 minus 5 is equal to 0. 2 times 1 is 2. 3 times 1 is 3. Minus 5 is equal to 0. Here, 2 plus 3 is 5, minus 5, which is 0. We have 0 on the left side and 0 on the right hand side. 0 is equal to 0 is a true statement. So, a pair, look at it, 1, comma 1. The first number represents x, the second number represents y. X is equal to 1, y is equal to 1. We can simply write it as 1, comma 1 in a bracket. That makes the statement true. So 1, comma 1 is a truth set, a set that makes this mathematical expression true. We're going to use 2x plus 3y minus 5 is equal to 0 in most of the time now. 2x plus 3y minus 5 is equal to 0. What about if x is 0? We've done when x is 1, as x is a variable, it can have different values. Let's give it now 0. What will happen if x is equal to 0? Let's see the value of y for x is equal to 0. When x is equal to 0, 2x is 2 times 0, which is 0. 3y, still y is not known, we keep it as 3y, minus 5 is equal to 0. So 0 is 0, we just don't need it anymore. 3y minus 5 is equal to 0. Now 3y minus 5 is equal to 0. When we remove minus 5 by adding a positive 5 up here, we have to add another 5 on the other side as well to maintain the balance. Now 5 and minus 5 here comes up to be 0. So we have only 3y on the left side, but we have now 5 on the right hand side. It simply means we can move 5 on the other side of the equality sign, but we have to change its sign. When it was negative, we have to put it positive. In other words, simply. So here, 3y is equal to 5. Y is 5 over 3. So, for the value of x when it is 0, y is 5 over 3. So, 0, 5 over 3 is another element that makes the mathematical expression 2x plus 3y minus 5 is equal to 0 true. So it is one true set. One set that makes the statement true. Can we have another true set? We keep doing that one for more examples to come up. 2x plus 3y minus 5 is equal to 0. If x is equal to now 2, What is the value of y? 2x is going to be 2 times 2 plus 3y minus 5 is equal to 0. 4 plus 3y minus 5 is equal to 0. Now we can move 5 on the other side by adding 5 on both sides, which I've said it before. 4 plus 3y is equal to 5. Let me now move also 4 on the other side by adding minus 4 on both sides. 3y is equal to 5 minus 4. 3y is equal to 1. 5 minus 4 is just 1. Y is equal to 1 over 3. This one, I have to divide both sides now by 3. So here 3 cancels out 3 and we have 1 here. 1y is equal to 1 over 3. 1y is simply y. So y is equal to 1 over 3. So when x is 2, I put it here, then y is 1 over 3. So 2 comma 1 over 3 is another set that makes the mathematical expression 2x plus 3y minus 5 true. Is there any other set of pair of numbers that make this expression true? Let's go for next one. 2x plus 3y minus 5 is equal to 0. The same one we are working on. When x is 3, we put 3 in place of x. 2 times 3 plus 3y minus 5 is equal to 0. 2 times 3 is 6 plus 3y minus 5 is equal to 0. Let's just add a plus 5 on both sides here. Then the 5 will be here, a plus 1. 6 plus 3y is equal to 5. Now again, add minus 6 on both sides of this equality sign. You will have minus 6 here to cancel out a positive 6 on the left side. Then you have another minus 6 on other side here. So 3y is equal to 5 minus 6. 3y is equal to minus 1. Now divide both sides by 3. This will be 1y is equal to minus 1 over 3. 1y is just a y. Y is minus 1 over 3 when x is 3. So this pair again, 3 comma minus 1 over 3. This is in terms of x comma y. We always write x first, y next. Is another set that makes this mathematical expression true. Okay, we continue to the next page and see. 2x plus 3y minus 5 is equal to 0 again. If x is 4, what is the value of y? 2 times 4 plus 3y minus 5 is equal to 0. 2 times 4 is 8 plus 3y minus 5 is equal to 0. 8 plus 3y is 5. I was adding plus 5 on both sides. Then this cancels out and I will have a plus 5 here. 3y is equal to 5 minus 8. Here when we add minus 8 on both sides, I will have minus 8 on this side. The left side will eliminate and gets to be 0. When it's 0, we don't need to write it then. 3y is equal to 5 minus 3, which is 5 minus 8, which is minus 3. y is equal to minus 3 divided by 3. You have to divide both sides by 3, then y is minus 1. So another set that makes this mathematical expression is when x is 4, y is going to be 1. All right, let's just do 1 or 2 more of this one to see more of the characteristic of this expression. Now, so far how many we got? 1 comma 1, 0 comma 5 over 3, 2 comma 1 over 3, 3 comma minus 1 over 3, 4 comma minus 1. These are all the solution sets of this mathematical expression. Means this mathematical expression represents a graph. Then these are pairs of numbers x comma y that is existing on this mathematical expression on the line. So here, what we have here, the value of x for this one is just 0 vertically. When we see x is 0, then y is somewhere just less than 2, which is 5 over 3 here. Which point is this one? This is somewhere at x is 1 and y is 1. When you see it from the x side, it is 1. From the y side, it's 1. This is 1 comma 1 here. Another one here, x is very much close to 2. Yes, x is 2. Y is somewhere less than half of 1 here. Just one third of it here. Here you can see this is y is negative, x is positive region here. So x is a little bit, it just looks like 3. X is 3 here, x is 3, y is negative 1 over 3. Look at y here. So this point is x3, y minus 1 over 3. This more of x gets to be more positive here. 4, y is less negative here. It's minus 1 up here. So these points are existing on the line. So this mathematical expression in arithmetic, in algebra, represents a line on the x and y axis. Here, this x represents the horizontal line here. This y represents the vertical line or axis. So we have x-axis and y-axis. This characteristic here, 2x plus 3y minus 5 is equal to 0, represents this graph or a straight line up here. This is a linear equation, or we can simply get it from a line, simple line, straight line up here. Let me go to next page. I sometimes take a few seconds to clear this page. At the end, I'm going to convert this one to PDF. So I want it to remain clean. Now, let's see this expression. 2x plus 3y minus 5 is equal to 0. This is the expression. Let's do a little bit on it without putting values for x and y. 2x plus 3y is equal to 5. 3y is equal to, I moved 2x into the right side. How I move it? By adding minus 2x on both sides. When I add minus 2x on both sides, the left side cancels out and to be 0. So only 3y remains on the left side. And the right side will be minus 2x plus 5. Now 3y is equal to minus 2x plus 5. When I divide both sides by 3, so on the left side I will have only one y, which is y is equal to minus 2 over 3x plus 5 over 3. I have a reason why I just write it this way. This is another way of writing equations of two variables. You can write it as we begin with ax plus by plus c is equal to 0. That is one form to write an equation of two variables. Another way is y is equal to, say, mx plus b. The reason why we do this one is this way of writing this expression gives us extra more information to know the characteristic of the graph on a number line, on a plane. This m stands for the slope of the graph, and the last piece of bit here, b, stands for the y-intercept. This y-intercept means a place where the graph cuts the y-axis. So m is the slope of the graph, b is a y-intercept. This y-intercept is a place where the graph cuts the y-axis. At a place where the graph is cut on the y-axis means the value of x is 0. On this vertical line here, 0 is where we can cut the y. if x is not 0, other than 0 somewhere here, there is no chance for the y to be cut. So y-intercept is found when x is equal to 0. Likewise, x-intercept is found, a graph cuts the x-axis where the y value is 0. Normally, the y-intercept is always a 0, comma y, and the x-intercept is always x, comma 0. When y is 0, that's x-intercept. When x is 0, that's a y-intercept. Put in mind this one. It might help later on. Slope, we can have different kinds of slopes. A positive slope, a negative slope, a zero slope, and an undefined slope. The slope is the vertical increase, the y increase, divided by the horizontal increase, the x increase. When the graph moves this way, it has got a better y increase. For such graphs, we call it is a positive slope. A positive slope graph is a graph in which, as you move from left to right, it increases in the y side. It increases. It's just like moving up stairs. We can consider that. It's just moving upstairs means a positive slope. When we have no much increase on the y side or a zero increase on the y side, this is a horizontal line. For a horizontal line, we have a slope. Letter M is used for a slope, 0. For a stepping up, we have a slope, 0. Our reference is moving from left to right. For stepping down graphs like this, we have a slope of negative. For a vertical line, something like that, we don't have a defined slope because you cannot put anything on a vertical line. You cannot put anything on a vertical line to assess how it increase or decrease. When you put it, it's all about gravity here. So there is no defined slope for a vertical line because the x increase is 0. The x increase is 0 means y2 minus y1, y increased, divided by there is no x increase, is going to be a number. It could be any number divided by 0. It is undefined. We cannot divide a number for 0. So a vertical line slope is undefined. More we are going to see, so not much to worry at this stage. We are going to talk more about slopes as we go forward. Again, the famous equation which we start with is 2x plus 3y minus 5 is equal to 0. Let's see how we can put it in the form of y is equal to mx plus b. That will help us to see the character of the graph better. 2x plus 3y minus 5 is equal to 0. 2x plus 3y is equal to 5. Why? We add positive 5 on both sides of the equal sign. Then on the left side, the 5 will be eliminated, and then on the right side, we will have a positive 5. Once again, add minus 2x on both sides. 3y is equal to minus 2x here, and plus 5. Once again, divide both sides by 3. Y is equal to minus 2 over 3, x plus 5 over 3. From this, y is equal to mx plus b format. Y is equal to mx plus b format. M is equal to minus 2 over 3. That's the slope. So this is a stepping down graph. A negative slope means stepping down through 0, comma b is a y-intercept. 0, comma 5 over 3 is a y-intercept. This is where 5 over 3 is a little bit less than 2. 5 over 3 is a y-intercept. So we put y-intercept in the form of 0, 5 over 3. That is the y-intercept. So this is a graph. We can simply see the character by putting the equation in the format of y is equal to mx plus b. If you want to see my little calculation up here, you can pause the video and you can have a look. Okay. Uh, any pair that's a true set for one is a true set for the other, means that the line is one and the same. Actually, it's there is something which I put a note for that. Here, our famous equation is, look at it, 2x plus 3y minus 5 is equal to 0. This one here. When you multiply both sides by 2, you will have 2x will be 4x, 3y will be 6y, minus 5 will be minus 10. 4x plus 6y minus 10 is equal to 0. So you only multiply both sides by a specific number, say 2 in this case. It means what? It means these two equations are the same. If you multiply the first one here by 3, you will have 6x plus 9y minus 15 is equal to 0. These three graphs are one and the same. It's all talking about the same graph. So it's a simplified form. Instead of 6x plus 9y minus 15, a simplified form of this expression is dividing both sides by a certain constant. Then 2x plus 3y minus 5 is a simplified form of it. But it is one and the same. So whatever makes this first one true is going to make the others also true, because it is the same graph. We're talking about one in the same graph. Just that's a piece of note which I put here. So we know we have already got pointers that satisfy the two variable expression 2x plus 3y minus 5 is equal to 0. These are 1.1, 0, 1, 1, 0, 5 over 3, 2, 1 over 3, 3, minus 1 over 3, 4, minus 1. So these are the pointers which are a true sets of this line. It's not the only. We have infinitely many of them. We have infinitely many pairs of numbers that makes this statement true, because this line is made of infinitely many pointers. So remember, slope is a vertical increase, a y increase, divided by a horizontal increase, the x increase. That we are going to calculate the slope of a linear equation later on. So given these pointers, we know these are 2x plus 3y minus 5. This equation has got these true sets. These are sets of numbers that are on the line. That makes the statement true. So a slope is a y increase divided by an x increase. Let's take only 2 pointers. 2 points are enough to decide the slope of a given equation. So 1.1 is one set, 0, 5 over 3 is another set. 1, 1 is one set here, 1 point here, and another point here. Given these 2 points, what is a vertical increase? The vertical increase is a y increase. So remember, the format is here x, y. So let's take, this is y2, the second y. Here is y1, the first y. y2 minus y1 is the increase of y. 5 over 3 minus 1. x2 minus x1 is the increase of x, which is 0 minus 1. So what happened here on the slope? Which is 5 over 3 minus, minus 1 is just minus 3 over 3 divided by minus 1. we have to make the denominator the same to do the subtraction on the numerator side, on the top side. Maybe in my previous lesson you can find this concept. So it is just like 5 minus 3 divided by 3 over minus 1, which is 2 over 3 divided by minus 1. Any number, positive number divided by minus 1 is a negative result, so minus 2 over 3. This is a slope. So the slope of our line is minus 2 over 3. We know it already. In the previous pages we discussed about that one. When we put it in the form of y is equal to mx plus b, if you remember, so y is equal to minus 2 over 3x. That was the slope of the line. We can do it once again here because it's here already. 2x plus 3y is equal to 5, right? Then 3y is equal to minus 2x plus 5. Y is equal to minus 2 over 3x plus 5 over 3. So a slope is minus 2 over 3. Y-intercept is 0, comma. X has to be 0 for y-intercept, we said. 0, comma 5 over 3. It's also here, the y-intercept up there. So we calculate the slope from given 2 points. More to do on this one. For other 2 pointers, 0, 5 over 3 and 2, 1 over 3, the slope is the y increase 1 over 3 minus 5 over 3 divided by the x increase 2 minus 0. We have to go the same direction this way. Or alternately, if we want to go that way, we can go also that way. But it's not allowed one to be like y2 minus y1, y2 minus y1, another one x1 minus x2. We don't do this one. Either y2 minus y1 divided by x2 minus x1, or y1 minus y2 divided by x1 minus x2. Only one direction. If we change the other direction, we are going to change the sign. So we will have a wrong slope. To mean here, x1 comma x2 is 1 point. Let me correct this one. Let me correct. x1 comma y1 is 1 point. x2 comma y2 is another point. So the slope is y2 minus y1 divided by x2 minus x1, or y1 minus y2 divided by x1 minus x2. On one direction we have to go, same direction we have to go for both x and y. Likewise here, for these 2 pointers, let me just finish the calculation up here. Okay, I will not have space, so I have to clear this one. Okay, 1 over 3 minus 5 over 3 divided by 2 minus 0, which is 1 minus 5 over 3 divided by 2, which is minus 4 over 3 divided by 2. 2 is just 2 over 1. Minus 4 over 3. When we bring out this one on the top, it will go to be inverted. 1 over 2. Instead of 2, it will be 1 over 2. Then this cancels out that one, which is minus 2 over 3. So the slope is again minus 2 over 3. For points 2, 1 over 3 and 3, minus 1 over 3, minus 1 over 3 minus 1 over 3 divided by 3 minus 2, which in this part you have minus 1 over 3 divided by 3 minus 1, which is minus 2 over 3 divided by 1. 3 minus 2 here. 3 minus 2 is 1, which is minus 2 over 3, the slope. A given line has got only a unique slope, only one slope. So if I take any 2 points on the line and I calculate for the slope, I will always get the same slope. If I get a different slope, means there is some calculation error. So given a slope and 1 point, if I have a slope and 1 point on a given graph, can I find the equation of the line or the graph? This is, we all talk about a linear equation, so a graph of a line. When we go to a quadratic equation, we will have a graph of a parabola, which is another section not in here to be covered. So given a slope here, minus 2 over 3, and I have 1 point here. When I have a negative slope here, I know I have to draw the graph like a downward. It's just moving downwards, right? But I have a point here, 1, 1, I know that. And I take any other point, but I call it a variable xy. The second line is going to be x, y. So what is the formula for a slope? A slope is y increase divided by x increase. Y minus 1 divided by x minus 1. From here, I have y minus 1. From here, I have x minus 1. The slope I know is minus 2 over 3. So what I get? I can do this a crisscross multiplication, we call it. Minus 2 times x minus 1 is equal to 3 times y minus 1. Minus 2x minus 2 is equal to 3y minus 3. This is called a distribution property. Let me bring everything to the left now. Minus 3y minus 2x minus 2 plus 3 is equal to 0. Okay. Minus 3y minus 2x plus 1 is equal to 0. Okay, let's see. I have okay, let me go to next page if I get more space to do this one, or otherwise I can do it somewhere around here. So minus 3y minus 2x plus 1 is equal to 0. That's the graph. I was given 1, 1 as one of the point on the graph, and I was given the slope, which is minus 2 over 3. So the slope is a y increase, y minus 1, divided by the x increase, x minus 1. The slope is given minus 2 over 3, which is equal to minus 2 over 3. When I do that crisscross multiplication up here, minus 2 multiplied by x minus 1 here is equal to 3 multiplied by y minus 1. Minus 2 times x is minus 2x. Minus 2 times minus 1 is a plus 1 here, is equal to 3y. 3 times y is 3y. 3 times minus 1 is minus 3. Here I have minus 2x plus 2. I have to change this one into plus 2. It's not minus 2. So this is a plus 2 here. It's a plus 3 here. I will have a 5 here. Minus 3y minus 2x plus 5 is equal to 0. Minus 3y minus 2x plus 5 is equal to 0. Or if I multiply both sides by negative 1, I can do that. 3y plus 2x minus 5 is equal to 0. I can write it that way also. If I want to write it in the format of y is equal to mx plus b, I will take this one. 3y plus 2x minus 5 is equal to 0. 3y plus 2x minus 5 is equal to 0. 3y is equal to minus 2x plus 5. Y is equal to minus 2 over 3x plus 5 over 3. The slope is minus 2 over 3. Yes, it is given here. The y-intercept is b. The value of b here, 5 over 3. X has to have 0 for the y-intercept, and then 5 over 3. This is a y-intercept. So this is a graph in different expressions. You can use this one, you can use this one, or you can use y is equal to minus 2 over 3 x plus 5 over 3. Any one of them can work.